Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U8. All right, for question number 1, it says if x and n are integers and then 9x plus n is negative, what is the largest possible value for n when x is equal to 2? So you have this expression here, 9x plus n, that's where we're going to start. And we know that this is negative, so we can set up an equality in which this is less than 0. Remember, negative numbers are less than 0, and you want to know what's the largest possible value for n. So, in other words, you want to maximize n when x is equal to 2. Now, you're given the value of x, so you can do a substitution here. And what that means is you're going to replace the x in this expression with the number 2. So this will turn into 9 times 2 plus n. It has to be less than 0. And then you could just go ahead and just solve for this inequality. So 9 times 2 is 18. So 18 plus n has to be less than 0. And remember, when you solve for inequalities, to solve just like regular equations, whatever you do to one side, you got to do to the other side. The only thing you got to watch out for is if you multiply or divide by a negative number, you got to flip the sign. So you have to flip the sign when you multiply or divide by negative numbers. So remember, for negative numbers, everything is flipped. So for example, 3 is less than 5, but negative 3 is actually greater than negative 5. And this is what happens when you multiply both sides by negative 1. Fortunately, though, we don't have to do that here. So if you just subtract by 18 from both sides, you don't have to flip the sign or anything. So I'll give you 9 has to be less than negative 18. Or n has to be less than negative 18, rather. So remember, n has to be an integer, which means it's a whole number. And the whole number that's smaller than 18, you just have to jump to the left of the number line. That means that the largest possible value is going to be n equals negative 19, which is choice B. Remember, negative 19 is the biggest possible value for n, because n could be negative 19, negative 20, negative 21, negative 22, etc., all the way down to negative infinity. Negative 19 is the largest one. All right, next, for question number 2, driving continuously, Brady can travel 240 miles in 4 hours. At this rate, how many miles can he travel in 3 hours? So this is a rate question, and for rate questions, you can use the unit rate. You can also use proportions. You can also use a formula, distance equals rate times time. So either method is fine here. Here, I think unit rate would probably be the easiest. So you have 240 miles. That's his distance, and this is in 4 hours. So to find the unit rate, you want to find out how far he can drive in just 1 hour. So to go from 4 to 1, you just have to divide by 4. So you also have to do that on the left side. So 240 divided by 4 is 60 miles. So this represents the unit rate. Now once you have the unit rate, you can then go forward into any time. Specifically, we want the time for 3 hours. So you got to go 1 times 3 to get you 3 hours. So you also have to do that to the left. If you times 3, you'll have 180 miles, which will be 3 hours. So each hour you drive 60 miles. In 3 hours, you'll drive 180 miles, which is choice C. All right, next, for number 3, if a student reads 12 pages of a book each night, which of the following is the closest approximation of how many pages the student will have read in 2 weeks? So this is also another rate question, and the rate here is 12 pages, and this is in 1 night. So you already have the unit rate. Now what you want to do is figure out how many days are in 2 weeks. Well, you know that 1 week is 7 days. So then 2 weeks will have to be 14 days or 14 nights. So of course 1 times 14 is 14, and you also have to multiply by 14 on the left. So you just have 12 times 14. You'll have about 168 pages, and 168 is the closest to choice A, because it's 2 away from choice A, whereas it's 3 away from choice B. So choice A is the best answer. All right, and here's a summary for this first page. All right, next for number 4, while playing darts, Larry hits the bullseye 15% of the time. How many darts will Larry need to throw in order to hit 6 bullseyes? All right, so here he hits a bullseye 15% of the time, and that means that 15% of the total has to be equal to 6. So here we want to figure out the total. How many darts he has to throw in order to make 15% equivalent to 6 bullseyes. We can also set this up using proportions or unit rate, just like what we did before. But in this case, we can use the equation method. Of means multiply here. And percent means divide by 100. So that becomes 15% becomes 15 divided by 100. And if you multiply by the variable t, you will get 6. Now, to solve for t, you have to multiply by the reciprocal, which is the upside down fraction. The upside down fraction is 100 over 15. And when you multiply by that, you cross cancel the 15 over 100. So you only have t on the left side. That's going to be equal to 6 times 100 divided by 15. Now, from here, before you multiply it out, you can cross simplify. So 6 and 15, for example, has a common factor of 3. So if you cross out 3, this common factor of 3, you have 5 in the bottom and 2 in the numerator. Then you can go 5 and the 100. You can cross cancel because 100 divided by 5 is just 20. So you have 20 and 1. So then the final answer will be 2 times 20, or just 40 divided by 1, which is just 40. So the answer will be choice B. Now we can check our work by multiplying 15% of 40. So if he throws 40 darts at the board, 15% of them will hit the bullseye. So that will be 15 over 100 times 40. And here you can cross cancel as always. The 0 cancels out there. 4 and 10 cancels for 2 and 5. And then 5 and 15 cancels from 3 and 1. And 3 times 2 is 6. So it would be 6 bullseyes. So that means that everything is correct. So the answer is choice B. All right, next for number 5. Set A is the set of all the even numbers between 10 and 20, and it's inclusive. And inclusive means that they're including the endpoints. Now, the members of set B consists of all the multiples of 3 between 7 and 19, inclusive. If set C is the intersection of sets A and B, how many members does C have? All right, so a set is just a list of numbers. And you use curly brackets to denote the elements in a set. So set A is a set of all the even numbers between 10 and 20, and includes both of them. So it'll be like 10, 12, all the way down to 20. So let me just rewrite that again. So it includes 10, and here you just have all the even numbers. So set A will have 1, 2, 3, 4, 5, 6 numbers, or 6 elements. And again, an element is just a number in the set. Then you do the same thing for set B, and set B is all the multiples of 3 between 7 and 19. Now, 7 and 19 aren't multiples of 3, so we just skip them. The first multiple 3 will be 9, then 12, 15, and then 18. So set B only has 4 elements. now finally for set C is the intersection of sets A and B, and this intersection means that it only has common elements only. So you have to look at both sets A and B and see what they have in common. So for set A and set B, the even numbers and also multiples of 3, see that 12 and 18 are the only two numbers that show up in both. So set C will have only 2 elements. So again, set C is the intersection. The symbol for that, by the way, is this upside down U. That represents the intersection. And here, you just want even multiples of 3 within the range, and that's only choice A, 2. One thing that's related to this is called the union. And the union is represented by the letter U. And in a union, it's all the elements together. So it's the everything set. You just put everything together, but don't double count. So for example, if you want the union of sets A and B, you will have 9, 10, 12, 14, 15, 16, 18, and 20. So I have a whole bunch of elements in there. But the 12 and 18 only count once. So again, A union B will be 9, 10, 12, 14, 15, 16, 18, and then 20. So it'll be 1, 2, 3, 4, 5, 6, 7, 8 elements. That's for the union. So that's just a variation of this question that is also possible on the test. All right, next for number 6 is half of a number is equal to 4 more than twice the number. What's a number? So here you have to turn the word sentence into a number sentence. Here, half of a number means 1/2 of a number, which we're going to call x, and that is equal to, which means equal sign, 4 more than twice the number. So 4 more than means plus 4, or 4 plus, and then you'll have to do twice the number, and that's going to be 4 plus 2x. So when we have this equation, half of x is equal to 4 plus 2x, got to put all the x's on one side, and here you would want to subtract 2x on both sides. So you move everything to the left. 1/2 minus 2x is going to be negative 1.5 x is equal to 4. You can also rewrite half of x as 0.5x. So this is really 0.5x minus 2x, which will be negative 1.5x. And here, you can't deal with these annoying mixed numbers, so you got to turn them into improper fractions. So that's going to be negative 3 over 2x is equal to 4. And to solve for x, you have to multiply both sides by the reciprocal. In this case, it will be 2/3, but it has to be negative because the negatives will cancel out, turn into a positive. So you have to multiply both sides by negative 2/3. This way, the 2 cancels out with the 2 in the denominator, 3 in the denominator cancels out with 3 in the numerator, and then the 2 negative signs also cancel out. So you just have x on the left side. It's going to be equal to negative 8 over 3. Remember, this is 4 over 1. So 4 times negative 2 is negative 8. And then 1 times 3 is just 3 for the denominator. So the answer is going to be choice B. All right, next for number 7, points F and G are the endpoints of a line segment, and FG is equal to 30. H and I lie on FG such that FH is 1/3 of FG and FI is 1/3 of FG. How long is HI? All right, so you just draw this number line. And here the length is 30. Now, h and I are on here such that f to h is 1/3 of fg. Well, fg, is 30. So 1/3 of 30 is equal to 10. So that means that f to h has to be 10. And then h to g has to be 20. Now, the other part is that f to I is 3/5 of fg. So again, fg is 30. So 3/5 of, remember, means time. So you're multiplying by 30. Your 30 and 5 cancels. Have a factor of 6 left over in the numerator, and 6 times 3 is 18. So that means that f to I has to be 18. So if f to h is 10 and f to I is 18, you can subtract 18 minus 10 to get this distance of just 8. Now you can also check your work. I to g will have to be 12 because 12 plus 18 has to be 30. And 10 plus 8 plus 12 is in fact equal to 30. So everything does check out. So the answer is choice B. All right, next for question number 8. During a rainstorm, a z ounces of rain collect in a bucket every y minutes. How many ounces of rain are collected in x minutes? So here you have z ounces in the bucket every y minutes. And from here you want to get the unit rate because this is a rate that compares the two different quantities, ounces of rain and minutes. So you want to know how many ounces of rain are collected in x minutes. So it's question mark ounces in x minutes. So here you can use unit rates or you can also use proportion. So let's use a proportion method here. And instead of question mark, you can just put that in a box or something. But either way, you would want to cross multiply because the units do line up. So you'll have z times x is going to be equal to y times question mark box. And to solve for the question mark, you're going to have to divide both sides by y. So the answer will be z times x divided by y. All right, so here the answer would be choice C. Not choice B, choice C. XZ, which is the same as ZX, but we just want y in the denominator. All right, and here's the summary for this page. All right, next for question number 9. In a certain parking lot, there are 2 silver cars, 3 blue cars, 4 red cars, and 3 white cars. There are no other cars in the parking lot. What is the probability that a car chosen at random from the parking lot is not blue? So here the keyword is probability, and a probability is just a chance. So what that boils down to is just part over whole. So the part that you want is the part that is not blue. So you want to know the number of not blue cars divided by the whole, which is the total number of cars. So for the not blue cars, you're going to want to count the 2 silver plus the 4 red plus the 3 white. And the total is going to be everything. So you're going to have to add 2, 3, 4, and 3. So then if you add everything up in the numerator, you'll have 9. In the denominator, you'll have 12. Now you have to simplify 9 over 12. And you can do that by dividing the numerator and the denominator by the the greatest common factor, which is 3. That'll give you 3 over 4. And that's going to be the final answer, which is choice D. Next for number 10, x to the 2/3 power plus 6 is equal to 10. Which of the following is a positive value for x? So the important part is this fractional exponent. And exponents can be fractions. And for a fractional exponent, it actually it boils down to 2 parts, the numerator and the denominator. So you have the base raised to the a over c power. the numerator is actually a power, and the denominator is a root. So b raised to the a over c can be rewritten as b to the a to the c root. Or you can also do the root first, the c root of b raised to the a power. So either one is fine. So the first thing you want to do here is to subtract 6. So you want to isolate the x. So when you do that, you'll have x raised to the 2/3 power is equal to 4, because 10 minus 6 is 4. And I can rewrite 2/3 as x raised to the 2nd power, and then the cube root. All right, then from here you can use inverse operations on both sides. The opposite of the cube root is really a power of 3. So if you raise both sides to the power of 3, you'll have x squared left on the left side. On the right side, you have 4 cubed, which is 64. And from here, you can do square root on both sides. That's the opposite of the power of 2. And you get x is equal to positive or negative 8. And you see choice C is here. But x could also be negative. All right, so we're going to fractional exponent. The exponent is a power, the denominator is a root, and there's 2 ways to express this. You could do the power first, or you could do the root. Next, for number 11, let f of x is equal to 7x minus 3, and let g of x equals kx minus x plus 10. If k is equal to 4, what is f of g of 5? So here you have a couple of functions. And a function is just an input-output machine. So what that means is you take some input x, you put it into this machine, which we'll call f, and you get y as the output. And y is equal to f of x, and that's how you would read this. Wherever you see x in this equation, you'll just replace it with whatever number goes into this machine. Now specifically here, you have a function inside a function, and that's called a composition of functions. So inside this function of f, you have another function of g. So what that means is, just like in the order of operations, you got to do the innermost parentheses first. You got to do g first. So first you take 5, this input, you put it into this function, this machine called g. You'll get g of 5. But then you'll take this input, or this output, and you'll put it inside the function f, and you'll get f of g of 5. So the output becomes the input. So wherever you see 5, you have to replace it. Wherever you see x, you have to replace it with 5. So you have to do g first. So inside g, you're going to do g of 5. So everywhere you see x, you're going to replace it with 5. Now k, is 4. So it's be 4 times that of x. You have 5. You'll be subtracting 5, and you want to add 10. So here you're going to do order of operations and multiply first. So that's going to be 20 minus 5 plus 10, which is equal to 20 minus 5 is 15 plus 10 is 25. All right, so g of 5 is equal to 25. You put 5 inside the function g, you get g of 5. That's equal to 25. But now this 25, you'll put into the function f. You get f of 25. You want to now figure out what that is. Function f is over here. So f of x is equal to 7x minus 3. So everywhere you see x, you'll replace it with the 25. you'll have 7 times 25 minus 3. And 7 times 25 is 175, and 175 minus 3 is 172. So that's how you would solve this composition of functions. It's a function inside a function, so you have to do the innermost function first. So just like the regular order operations, you have to do the innermost function first before you do anything else. All right, next for number 12, in the rectangle ABCD above, if ABE is an equilateral triangle and BC is equal to 9, what's the sum of the lengths of AE and BE? All right, so ABE is equilateral, which means that all sides are equal. Again, figure not drawn to scale. It looks isosceles, but it's actually equilateral. Now, BC is equal to 9. Now you want to figure out the sum of the lengths of AE and BE. All right, so for an equilateral triangle, remember all the angles are 60, 60, 60 because all the angles are equal, so are all the sides. Now, if you know that the side of a rectangle is 9, you can actually cut this equilateral triangle in half, and that will give you two 30, 60, 90 triangles. And this is one of these special right triangles. For a 30, 60, 90 right triangle, the sides are in a ratio of x, 2x, and x root 3. And here, this x root 3 side is actually equal to 9, because that's the same as the side of the rectangle. So this height, or this part of the 30, 60, 90 is 9, so that corresponds with that piece. So from here, you can set an equation. X root 3 is equal to 9. To solve for x, you can want to divide by root 3. That will cancel out the root 3, so that will give you x is equal to 9 over root 3. Now you can simplify this fraction by rationalizing the denominator. So right now the denominator is an irrational number. You can't have that. So you can rationalize the denominator by multiplying by root 3 divided by root 3, which is just a form of 1. So you just find equivalent fractions. So the numerator becomes 9 root 3. The denominator becomes root 3 times root 3, which is equal to 3. And from here, 3 is a rational number. You can cross cancel it with the 9. And that will give you 3 root 3. So that's what x is equal to. And the hypotenuse is equal to 2 times that, so that's going to be 6 root 3. And same for AE. So now what you want to end up doing is to add the two 6 root 3s, because that's what this problem is looking for. And these are actually like terms, so just add the coefficient. You get choice C, 12 root 3. So again, the key here was this 30, 60, 90 special right triangle. And you can use that to figure out the sides. If you forgot that, that's okay. You can also use Pythagorean. So that means you have to substitute into a squared plus b squared is equal to c squared, and that takes a long time. The shortcut is, of course, memorizing the 30, 60, 90 special right triangles. All right, next for number 13. In a deck of cards, there's a ratio of 4 to 3 for spades to clubs. Which of the following statements about the number of spades and clubs must be true? So in this deck, you have 4 to 3 for spades to clubs. So that means there are 4 spades to 3 clubs. So each time you have 3 clubs, you have 4 spades. So if you kind of work this out, you know that you'll have some multiple of this. So you'll have 6 clubs and then 8. You just have the times tables. So you have to go through all the choices, see which one is true. For choice A, the sum is an odd number. Well, 4 plus 3 is odd. That's fine, but it could also be any multiple. For example, 8 and 6. There's also a ratio of 4 to 3 once you simplify, but 8 plus 6 is 14. So it can't always be odd or even. You can eliminate choices A and B. Again, the keyword here is actually must, and must means 100% of the time true. So A and B are sometimes true, so we can't have that. Same thing for choice C. They have to have a multiple of 5. Well, 4 times 3 is not a multiple of 5. It's 12. 12 is not a multiple of 5, so choice C is wrong. 12 is, in fact, a multiple of 12, so that could be it. And we can also eliminate choice D. The product is a multiple of 36. That's not true. 12 is not a multiple of 36. It's too small. The second one, 8 times 6, is equal to 48, and 48 is also not in the 36 times table, so we also eliminate choice E. The answer has to be choice D. Again, must means 100%, so you just list a couple of potential number of cards in this deck, and you can eliminate the choices one at a time. All right, and here's the summary for this page. All right, next for number 14, if 2 times the square root of x minus 8 is equal to 7y squared, what is x, the value of x in terms of y is? So if you hear anything like this, what you actually have to do is to isolate the first thing in that phrase. So in this case, it's x. You want to get x by itself. So you could do that by doing inverse operations. What do you do to one side? You got to do to the other side. So the first step is to divide by 2. So once you do that, you'll have the square root of x minus 8 is equal to 7 over 2 times y squared. Then you want to do the inverse of the square root, which is an exponent of 2. So that will give you x minus 8 on the left side, and on the right side, you'll have to apply this exponent to everything inside the parentheses. This is the law of exponents that states that a times b raised to the c power is a to the c times b to the c. Kind of like the distributive property of exponents. So when you do that, you'll have 7 over 2 squared times y squared squared. And then from here, you can do power to a power, which is b to the a raised to the c power is b to the a times c. So we'll want to multiply this 2 and this 2. And then you also want to distribute this 2 again to the numerator and the denominator. That's the same as the first law that we talked about. A over b raised to the c power is a to the c divided by b to the c. So that'll give you x minus 8 on the left to 7 squared over 49 divided by 4 times y to the 4th. And then last but not least, you can want to add 8 to both sides. And now they're not like terms at all, so you end up with x being isolated on the left. We go to 49 over 4 y to the 4th plus 8, and that's choice B. All right, next for number 15, the half circle shown above has a radius of 6 and the center is D. If AC is perpendicular to BD, what is the area of the shaded region? So here you have a radius of 6, so you can fill that in. So if this circle, and again it's a half circle, and the center is D, so you know that the radius is 6 to either side. So DA and DC, they're going to be equal, as well as ZB. Now AC is perpendicular to BD, so you know these are right triangles. And for a right triangle, that's inscribed in a semicircle. In this case, you have 2 sides that are equal. This is an isosceles right triangle, or a 45, 45, 90 special right triangle. And the sides are going to be in a ratio of x, and x root 2. You can also use Pythagorean to figure that out, which is a squared plus b squared is equal to c squared, but this is a lot faster. So you know that the hypotenuse is going to be 6 root 2. Right, now you actually want the area of the shaded region. So once you figure out that it's a 45, 45, 90, you can first do the area of the total. So the area of the shaded is going to be the area of the total semicircle, subtract the area of the triangle. So first we're going to find the area of the total, which is a semicircle, and that's 1/2 pi r squared is just the full circle, but divided by 2. So the radius is 6. So you want to do 1/2 times pi times 6 squared. Then you'll subtract the area of the triangle. Now the area of a triangle here is 1/2 base times height. And both the base and the height are equal to 6. So here, if you use the exponents first, remember the exponent is, you have to do that first in the order of operation. So 6 squared is 36. 36 over 2 pi, subtract 36 over 2. So that's going to be 18 pi minus 18. And that's going to be choice B. All right, next for number 16, if b is greater than 0 and b is equal to negative a, which of the following must be true? So again, must means 100% true. And here to do these questions, it's really helpful if you substitute in numbers and then just go through all the choices and use process of elimination. So for example, b has to be positive. So we can make b equal to, let's say, 1. And then b is equal to negative a. So 1 is going to be equal to the negative of negative 1. So b has to be equal to 1. A would be equal to negative 1 because the negative of a negative number becomes positive. So basically what you figure out is that a and b are additive inverses. Just a negative version of, a is a negative version of b. So you just go through all the choices. For example, choice A, you have negative of a, which is negative 1, cubed. And that's equal to b, which is 1 cubed. Now here you have to do order of operation. So the exponent comes first before you multiply or divide by a negative sign. So negative 1 raised to a third power is actually negative 1 again. Any negative number raised to an odd power is negative. A negative number raised to an even power is positive. That's because the negatives will cancel out. Here, the negatives don't cancel out. So you have negative of negative 1, and that's equal to positive 1, and that's also equal to 1 cubed, which is also equal to positive 1. So A is true for B, for 1 and negative 1. But let's just go through all the choices to see what happens. So for choice B, it's a little different. Right, for choice B, if you have the negative a cubed inside the parentheses, and you want to compare that to b cubed, well, b cubed we know is 1. Negative a cubed, yeah, you have the parentheses here, but these parentheses don't actually do anything, so it looks different, but it's actually the same as above. 1, of course, is not less than 1. That's totally wrong. So we can eliminate choice B because we found a case that made it false. So you would eliminate that. For choice C, you have B times A. In this case, that's going to be 1 times negative 1 raised to the third power. And that's supposed to be greater than B, which is 1. So 1 times negative 1 is negative 1. And negative 1 cubed, just like what we did before, is equal to negative 1, because it's the negative number raised to an odd power. And negative 1 is not greater than 1, so we can eliminate choice C as well, because negative 1 is smaller than 1. Next, for choice D, you have a squared and b squared. So b squared is going to be 1 squared, and you want to see if that's greater than negative 1 squared. Well, both of these are going to be positive 1. So 1 is not greater than 1. Again, you eliminate choice D. Finally, for choice E, you have a negative b in parentheses. So this is different because you have to do the multiplication of negative 1 first. So this is negative of positive 1 cubed, and that's going to be equal to negative 1. On the right, you have the negative of a, and the negative of a is this negative of -1. Okay, a itself is equal to -1. So when you substitute in -1 for a, the negative of -1 will be positive. So this will turn to +1 cubed, which is equal to +1. And you know that -1 is not equal to +1. So choice E is also wrong. The answer has to be choice A. So here for these types of questions, remember, all you have to do is find a test scenario and then just go through all the choices and see if you make them true or false. Now, if it's must be true, what that means is that if you find a case that makes it false, you know there's wrong, so you can just eliminate it. And then you'll have to keep doing that and eventually have one choice left. In this case, it'll be choice A. All right, next for number 17, the first three terms of a geometric sequence are k, 6k, and 36k. For how many values of k between 1 and 10 inclusive does the sequence contain only even integers? So the first thing to note is that a geometric sequence. So sequence is just a list of numbers. And a geometric sequence is one in which the pattern is to multiply. So you have to multiply a constant to get to the next term. That's as opposed to a arithmetic sequence where the pattern is by adding or subtracting. Here you are multiplying. So the first terms are k, 6k, and then 36k. So here you can kind of see the pattern is times 6. Now, here you want to go through how many values of k between 1 and 10 does the sequence contain only even numbers. So you just substitute in, if k is equal to 1, you'll have 1, 6, 36. Here, 1 is not even, so you can eliminate 1. Then you go substitute in 2, and that's 2. 6 times 2 is 12. And 36 times 2 is 72. So everything's even, so you circle that. And if you substitute in 3, you'll have, of course, the first term will be 3, so that would make it wrong. When you substitute in 4, you'll have 4. 6 times 4 is 24. And then you want to multiply by 6 again. And you'll get 144. All right, so then if k is equal to 4, they're all even. You kind of see a pattern. Every time k is an even number, you'll have all three are even. Because you have even, to get to the next number, you got to times 6, which will still be even, because even times even is even. And times by 6 again will be also even. So here, you want to figure out, well, how many even numbers are between 1 and 10? Well, between 1 and 10, inclusive, which includes the endpoints. What that means is that you have to include 10. So that's 2, 4, 6, 8, and 10. For those 5 numbers, choice B, this geometric sequence is only even. All right, and here's the summary for this page. All right, next for number 18, in the figure above, AC and BD intersect at point E. If the measure of angle ABC is 80, and the measure of angle BCE is 50 degrees, and the measure of angle CEB is 3/4 of the measure of angle ABC, what fraction of the measure of angle CEB is BAC? All right, so the measure of angle ABC is 80. So we can replace this piece with 80. So 3/4 of 80 will be 60 degrees. The 80 and the 4 cancels to give a factor of 20. So then 20 times 3 is 60. So now the measure of angle CEB has to be 60 degrees. All right, so now you have a triangle, triangle BEC. And you know that for triangle, the angles add up to 180 degrees. So far you have 60 and 50, which adds up to 110. And 180 minus 110 is going to be 70. So you know that the measure of angle CBE is 70 degrees. And that leaves the measure of angle ABE to be just 10, because you know that 70 plus 10 has to be equal to 80. All right, so now we actually have another triangle that we can make, because you want the measure of angle BAC. And BAC is over here. So you have this larger triangle, triangle ABC. And again, this triangle, of course, is 180 degrees. So you have angle B, which is 80 degrees, or angle ABC, which is 80 degrees, angle BCA, which is 50 degrees. That's equal to 130 so far. 180 minus 130 is equal to 50. So you know that angle BAC has to be 50 degrees. Now you want fraction of measure angle CEB. This of is the whole, and this is the part. So remember, it's an is of question. It's just part over whole. So what fraction of the total of CEB, which is 60, is the part that's BAC, which is 50? So the answer is going to be 50 over 60, or choice E, 5/6. All right, so again, the key here was to use the fact that triangles add up to 180 degrees. All right, next for number 19. Which of the following is the most simplified form of the expression 12x squared minus 18xy minus 54 y squared divided by 6y squared plus 4xy? All right, so here, the first thing to do is in the numerator, you can actually factor out a factor of 6, because 12, 18, and 54 can factor out a 6 out. So the numerator will have 6 on the outside, and you'll have 2x squared minus 3xy minus 9y squared. All right, now for the denominator, you can factor out 2y. So if you factor out 2y, you'll have just 3y first, because again, you're just dividing here by 2y. And then for 4xy, if you divide that by 2y, you'll still have the 2 and the x. And you have to divide both of these fractions. So first up, the 2 is gone. You can divide by that. So you just have that 3 left. So far you still have 3, parentheses 2x squared minus 3xy minus 9y squared, divided by 3y plus 2x. All right, and now here, kind of want to, divide by something to get rid of these common factors. So you're going to have to guess and check when you FOIL or factor the numerator. Now, the trick here is that you can use the denominator to try to cancel out some common factors in the numerator. For example, see a 3y here. You know that 3y times 3y, or 3y squared, is equal to 9y squared, and that's what we have there. So you know that here, if you have a negative, you're going to want to have a minus 3y as one of the terms. So remember, you're trying to divide and get rid of the denominator, because we're trying to guess that maybe is a factor. So then when you do the factoring, which is the reverse of FOILing, when we have first, outer, inner, last, the negative 3y times the positive, there should be a 3. The negative 3y plus times the positive 3y will be the 9y squared, negative 9y squared there. Now what you still need to do is to get the first terms. All right, so remember for the first terms, you have this, that, whatever this is. So this times the 2x, try to make it into 2x squared. So you can just put an x there and see if that will cancel it out. So x times 2x will be 2x squared. That's the first. The outer will be x times positive 3y, or plus 3xy. The inner will be here, will be negative 3y times positive 2y, which is negative 6y, 6xy. And finally, the last will be negative 3y times positive 3y, which will be negative 9y squared. And here, when you combine like terms, the middle two are like terms. You have 2x squared plus 3xy minus 6xy gives you minus 3xy. And then you have the minus 9y squared. So there you go. This is equal to the numerator. So this is the check. So the numerator actually boils down to 3 times x minus 3y, this first factor, times 2x plus 3y, the second factor here. And the denominator is 3y plus 2x, which will allow you to cancel out the 3y plus 2x, and you just have this piece left over, divided by this y. Forgot about that y there. So it'll be 3x minus 3y divided by y. And here you don't see that as any of the answer choices, but if you were to distribute the 3, you'll have choice C, which is 3x minus 3y, minus 9y, all over y. So for number 19, you have to factor, and you have to kind of guess and check by using the denominator as one of the factors to kind of reverse engineer and just backtrack, work backwards to get the other factor. All right, next for number 20, a sphere with a radius of 4 is inscribed in a cube whose edge length is 8. What is the distance from the center of the sphere to the corner of the cube? All right, so here you have a cube, and you have a sphere, which is just a ball, inside it. Anyway, so for this, let me redraw this. All right, so here you have this cube. All right, there we go. So you have the sphere inside this cube with a radius of 4. So if you measure the other side, the diameter is going to be 8, which is the side of the cube. And I want to figure out the distance from the center of the sphere to the corner of the cube. So if you kind of break this down into a smaller cube, you can actually break this down into a smaller cube with a side length of 4. So what you're trying to find is the diagonal of the smaller cube with a side length of 4. And to do that, we can actually use this formula for a cube with a side length of s. The diagonal is always going to be s root 3. So the answer is going to be choice A if you know that shortcut. Now, if you don't, it actually turns into 2 Pythagorean theorem, which is a squared plus b squared is equal to c squared. So in order to find this diagonal of this cube, you have to first draw this right triangle. that kind of cuts across the slanted diagonal of the base. So the first thing to do is then find the diagonal of the base. So this side is just the side of the cube, which is 4. And here, this is the diagonal of the base. And the base is a square, so this is the top view. The base, of course, is a square with side length of 4. The diagonal is going to be the diagonal of 45, 45, 90, or 4 root 2. Remember, it's a 45, 45, 90 special right triangle. So the side's going to be xx and x root 2. You can also do Pythagorean to figure that out, but the diagonal is going to be 4 root 2. So now you can use Pythagorean for 4 for root 2, and you can call the diagonal c. So you just substitute it into Pythagorean. So this is the right triangle that we're looking for. It's 4 for root 2. And c, you have a squared, which is 4 squared, plus b squared, which is equal to c squared, and that's 4 squared plus 4 root 2 in parentheses squared is equal to c squared. Here you have to distribute this exponent of 2. So you have 16 plus 16 times 2, because you have the square root of 2 squared. And that's equal to c squared. So that's 16 plus 32, which is equal to 48. And when you do the square root of both sides, you get that c is equal to square root of 48. And 48, you would have to find the perfect square factor, which is 16 times 3. So that's the square root of 16 times the square root of 3. And the square root of 16 is 4. So the diagonal is equal to 4 root 3, just by doing Pythagorean twice. Now the shortcut, of course, is using this formula. But if you don't know the formula, this is actually where it comes from. It comes from Pythagorean just twice. So the answer is choice A. And here's a summary for this page. All right, for number 1, according to the information given in the table above, what was the overall increase from 2000 to 2001 in the number of parking violations for September through December? So here you have to look at the overall increase from 2000 to 2001. So to get the totals, you have to add both of these columns for 2000 and 2001. So for 2000, here that's 10. All right, so for 2000 you have 107. And then for 2001, it's a 10, and that's 12. It's going to give a total of 22. Right, so the total for 2001 is 122. Now the overall increase, you're going to have to do 122 minus 107. And you get a difference of choice B, 15. Next, for number 2, if x is equal to 7, then the absolute value of 5 minus x is equal to. So here you have to just replace the x with 7. And that gives you the absolute value of 5 minus 7. So here, if you complete the inside of the absolute value, you have 5 minus 7, which is negative 2. Now the absolute value will actually do its job here. And the absolute value gives the positive distance to 0. So what that means is you want to figure out how far away negative 2 is from 0, and negative 2 is 2 away from 0. Essentially, it turns a negative number positive. And positive numbers and 0, they don't change. So here, it turns into just 2, which is choice B. All right, next one, number 3. In the figure above, line OP has a length of 3 root 5. What's the value of A? So here, it really helps if you draw a right triangle by drawing the altitude and going down to the x-axis. So here, a is a negative number, but the distance here will just be the positive version, and the height here will be 6. So you go 8 units to the left, which is really just 3 units to the left, and then 6 units up. And the length should be 3 root 5. Here, the way to do this is to actually use Pythagorean, so you don't actually know if this is drawn to scale, for example. So we don't know what a is. Obviously, you can count the 3, but you don't really know if the scale could be 2 or 3. So to figure out what a is, we have to use Pythagorean, which states that a squared plus b squared is equal to c squared for a right triangle. So you have this a squared plus the b squared, which is in this case 6. That's equal to c squared, or 3 root 5 in parentheses squared. So here you're going to have to distribute the exponent, and that'll give you a squared plus 36 is equal to 3 squared times the square root of 5 squared, or 9 times 5, which is equal to 45. So a squared plus 36 is 45. To solve for a, you have to subtract 36 from both sides. That'll give you a squared is equal to 9, so a could be equal to positive or negative 3. And here we see both positive and negative 3, but remember a is in, or the point P is in quadrant 2. So quadrant 2 has negative x's and positive y's. So you only want a to be equal to negative 3, not positive 3. So the answer will be choice B. All right, next for question number 4, if m is a negative number, which of the following is also negative? So if m is a negative number, what you can do is substitute in any negative number. Let's say negative 1. And you substitute it in, and you want to know which one has to be negative. So for choice A, for example, you have negative m. So you have negative of negative 1, which is m, and the negative of negative becomes positive. So A is wrong. For choice B, you have negative 1 over negative 1, and 1 divided by negative 1 is negative 1. So you have a negative of negative 1, which is equal to a positive 1. So again, B is positive, so that's wrong. For choice C, you have negative m, which is negative of negative 1, but it's being squared. So this will give you, parentheses, it just turns into 1 squared, which is still 1. Remember, anything squared has to be positive or 0. So C is also wrong. For choice D, you have negative 1 squared, or negative 1 times negative 1, which will be equal to positive 1, so that's wrong. So the answer has to be choice E. If you have a negative on the outside of this m, here you have to do the exponent first before you multiply or divide, because the order of operations. So this would be negative of negative 1 squared, which you have to raise to the second power first. So that will be negative of positive 1, which is negative 1. So that's why E is always negative. The negative of m squared will always be negative, because m squared is always positive. All right, next for number 5, a polygon ABCDE is drawn on a coordinate plane. How many lines with a negative slope can be drawn from point O to a vertex of the polygon? So here you just have to draw lines to connect each of the vertices, and you want to have a negative slope. So remember, a positive slope will look like this. A negative slope will actually go downwards. So when you go left to right, you're going downhill. And we see that twice. From O to C, and also from O to E. All the other lines will have positive slope. So the answer is choice C. Next for number 6, the members of the Superstars diving team have only 2 training programs. There are 10 team members in training program A and 17 members in training program B. If 3 of the team members in training program A are also in training program B, how many divers are on the team? So there are two training programs, A and B. Some are on both. So you want to draw a Venn diagram here. Now, 3 people from A are also in B. So that's 3 in the middle. And now for the A circle here, we know that there are 10 in circle A. So 10 minus 3 has to be 7. So 7 people are only in A. And then for the B circle, there are 7 members for B. So this circle here has to represent 7. So here 7 minus 3 is 4. So there are only 4 people who are only on team B. Their total is going to be 7 plus 3 plus 4 or 14. Choice B. All right, and here's the summary for this page. All right, next for number 7 in the figure above, what is the area of triangle LMN? So here the area of a triangle is given as 1/2 base times height, where base must be perpendicular to height. Here, because you have LM and LN on the axes, you know that this has to be a right angle because the x and y axis are perpendicular. So here you just have to figure out the length of the sides. Well, from L to M, it goes from this 0 to this length of P. So P minus 0 is equal to P. Now for Ln, you have to look at the change in x, which is from 0 to P. So here P minus 0 is also P. So the area is going to be, or the base is going to be P. The height is also going to be P. So the area is going to be 1/2 base times height, or 1/2 P times P, which is 1/2 of P squared. And that's choice A. Okay, next for question number 8 in the figure above, lines X is parallel to line Y. So you can draw this symbol here to represent the parallel nature. Now, if E is equal to 1/4 of B, which of the following must be equivalent to A plus C? All right, so E is 1/4 of B, and B is this angle here. Now, because you have parallel lines, you know that this angle B is also equal to this angle over here. And that's because we have a classic setup called corresponding angles. So corresponding angles, they form this letter F. And the angles here are congruent. So I always look for the letter F here. So in this case, B is equal to this angle over here, and that makes angles E and B supplementary. So supplementary means a straight line, and they add up to 180 degrees. So you know that E plus B has to be 180, but you're given that E is equal to 1/4 of B. So then you can replace the variable E with 1/4 of B. So you can do a substitution there. I'll give you 1/4 of B plus B is equal to 180. And when you combine like terms here, 1/4 of B plus B is equal to 5/4 of B, because remember this B is really 4/4. That's equal to 180. To solve for B, you have to multiply by the reciprocal, which is the upside down fraction, which is 4/5. And you do that because you can cross simplify. The 4 cancels out with the 4. The 5 in the numerator cancels out with 5 in the denominator. On the left side, you just have B, which is what you want. And that's equal to, here on the right side, 180 and 5 also cross cancels. We have 36 left over, so B will be equal to 36 times 4, or 144. Now, B is equal to 144. You actually want to know the value of A plus C. So A and C are actually the supplements of B. So you have to do 180 minus 144. That will give you 36. So A would be equal to 36, and C would also be equal to 36 because B and C are perpendicular, and so are A and B. Or supplementary, I should say. And A is also equal to C because they're vertical angles. So you do 36 plus 36, and that's equal to 72, which is A plus C. And that's choice C here. So the key here is to use corresponding angles, which are congruent, as well as supplementary angles, which adds up to 180 degrees. All right, next for number 9. In a sequence of numbers, the first term is 6, and each successive term, so each of the next terms following the first, is calculated by adding 2 to the previous term, and then dividing by -1. What is the value of the 100th first term subtracted from the 70th term? So here, just write out the pattern. So the first term is 6, and then to get the next term, you have to add 2, so 6 plus 2 is 8, and then divide by -1, which will give you -8. And then the next term will be adding 2, so it'll be -6. And then when you have -6 divided by -1, you get +6. And then to get to the next term, you would add 2, which will give you +8, but you have to divide by -1, which will give you -8. And you kind of see a pattern here. Basically, the odd term, so for the first, third, fifth, will always be 6. Whereas the even numbers will be -8. So here, if you want the 100th first term, that's an odd number, so that has to be +6. Whereas the 70th term is even. 70 is an even number, so this has to be -8. So the value of the 100th first term, which is 6, subtracted from, so you wanted to subtract 6 from -8. So the answer will be -8 minus 6, which is -14. And that's choice D. So just be careful here. Remember, when you subtract from, this means that the -8 is first. Next one, number 10. For all non-zero values r, s, and t, 2 raised to the -3rd power times r squared times s raised to the -4th times t cubed divided by 5 r to the -4th times s squared times t to the 3rd power is equal to. So here, we have to use this law of exponent that specifies that b to the a divided by b to the c equal to b to the a subtract c. So you have to subtract exponents when you are dividing. So here you can actually treat the r's together, then the s's together, and finally the t's together. And then 2 raised to the -3, a negative exponent, b to the -a is 1 over b to the a. It's a reciprocal. So 2 raised to the -3rd is really 1 over 2 cubed, and you're dividing that by 5. So that's the constant part here. For the r's, r squared divided by r to the -4 will give you r to the 2 minus -4, which will be r to the 6th power. Then for the x terms, it's s to the -4 divided by s squared. So this is s to the -4 minus 2, or s to the -6. And finally for the t's, the t cubes actually, they just cancel out. So t goes away. And now from here, you can actually simplify even further. So here, s to the -6, you're going to reuse this law again. So that will give you 1 over s to the 6th. R to the 6 is still in the numerator, so you can put r to the 6 over 1. And finally, 1 over 2 cubed is the same as 1/8. So here you have 1/8 divided by 5. And you can rewrite that. 1/8 divided by 5, you can rewrite as 1/8 divided by 5, and then you'll have to keep change flip, which will be 1/8 times 1/5, which will give you 1 over 40th. So you have 1 over 40th times r to the 6th times 1 over s to the 6th. So this is how you would simplify this. That will give you r to the 6th over 40 times s to the 6th. That's the final answer when you multiply the numerators together and multiply the denominators. And that's choice C. So here you have to use a lot of the laws of exponents, specifically this one where you subtract the exponent when you divide, and a negative exponent means reciprocal. And you might have to keep doing flip somewhere in there. All right, so 11 and 12 refers to this info. You have a phone company with 2 different plans. Plan A is 35 cents a minute, whereas Plan B costs $20 a month for the first 300 minutes, and then 15 cents a minute for each minute over the first 300. Now, if M represents the number of minutes Monty spent on the phone each month, in terms of M, what is Monty's monthly phone bill on Plan A? Well, Plan A says 35 cents a minute, which is no monthly fee. So if she spent M minutes talking on the phone, you just have to multiply this by 0.35, and that will give you the total, and that's choice B. All right, so here's a summary for this page. And then for question number 12, which is also related to the question before, which of the graphs given below illustrates the relationship between the number of long distance minutes used and the monthly cost for Plan B? So you want to take a look at Plan B. So Plan B starts at $20 a month for the first 300 minutes. So $20 for 300 minutes. So that means that if you have minutes on the x and cost on the y, the x coordinate, the x axis, where the plan starts will be 300, and it'll cost $20. So it'll actually start at 300 and 20. So that will start here. So you have to go through all the choices and kind of figure out, well, which one will start kind of at that point. Because even if you use it for, 0 minutes or 1 minute, 2 minutes, 3 minutes, 4 minutes, it'll cost you $20. So between 0 to 300, it'll cost you $20. So it has to have a flat line at 20. So choice A doesn't have that. Choice B, C doesn't have that. So it's down to just D and E. Now after this, though, we'll start increasing 15 cents a minute afterwards. So this represents the slope of the line. So what that means is that the cost will go up from here. Each minute after that, it'll go up 15 cents for each 1 minute. So it'll go up 15 cents for each minute. And you have to keep doing that. And that, of course, is your rise over run. That's your slope. And only choice D has that. Choice E doesn't mean that, because choice E means there's a flat rate. You can talk as long as you want, and it'll cost the same price. So that's not what this plan says. So this plan says that after 300 minutes, which is here, it'll cost more than $20. So your cost will then increase. Now, the slope is still less than the slope of the first plan, so sometimes it might be worth it to go to Plan B. But other times, if you don't talk around that much, Plan A might be cheaper. All right, next for number 13. For all real numbers, f of x is equal to x squared plus 1 divided by 2. If f of a is 25 and f of 11 is b, which of the following could be a value of b minus a? All right, so here you have a function, and a function here, of course, is an input-output machine. Just got to follow the rules. So here, f of a is equal to 25. So everywhere you see x, that's going to be a, that's the input, and the 25 is the output. So everywhere you see x, you're going to replace it with a, So f of a will be equal to, instead of x squared plus 1, it will be a squared plus 1 divided by 2. And this will be equal to 25. Now you can solve for this variable a. First step, multiply by 2 on both sides. So you get that a squared plus 1 is equal to 50. Then you subtract 1 from both sides, you get that a squared is equal to 49. And here, if you do the square root, you get that a is equal to the positive or negative 7. Remember, it could also be equal to negative 7, because negative 7 squared is also positive 49. So a could be positive or negative 7. They have to do the same thing for b. So for b, you have f of 11. So f of 11 means everywhere you see x, you'll replace it with 11. That's 11 squared plus 1 divided by 2, and that's 121 plus 1 over 2, or 122 over 2, which is equal to 61. So that's equal to b. B has to be equal to 61. There's no other choice. So if you do b minus a, you could actually have 61 minus 7 or 61 minus negative 7. So it could either be 54 or it could also be 68. I don't see 54 as a choice, but I do see 68, so that's going to be choice C. So for number 13, just about reading functions. All right, next for number 14, Lois divides her birthday candy to T equal piles. If she gives 3 piles to her friend Merrick, in terms of T, which of the following represents the percent of her candy that she has left? All right, so she has birthday candies into T equal piles. And she gives T, 3 of them to Merrick. So she has T piles. And now she gave away 3. So now she only has T minus 3 piles left. All right, so this is her part. Her whole, she used to have T piles. So this is the part that she has left. It's T minus 3 divided by T. Now there's a fraction. To turn a fraction into a percent, you have to multiply by 100 and put a percent symbol. So this 100 is really 100 over 1, and that's choice A. It's T minus 3 in parentheses times 100 divided by T, and that's your percentage. All right, next for number 15, the number of baseball cards in Caleb's collection doubles every 3 months. If, after 9 months, he has B baseball cards, then an expression for the number of baseball cards in his collection after Y years is given by. So here, the number of cards that you have doubles every 3 months. So after 9 months, you have B baseball cards. So you can kind of work backwards, but here, if you go backwards, for example, you have 6 months and then 3 months. 6 months, basically before, 3 months before, you'll have half of that, so that's B over 2. And then at the 3 month mark, you have B over 4. So you go back again, you'll start off with B over 8. So let me rewrite that. So to start, you have B over 8, and after 3 months, you have double that, which is B over 4. After 6 months, you have B over 2. After 9 months, you have B. All right, so you have that. Now, what you want to do is take an expression for the number of baseball cards in his collection after Y years. So after Y years, you want to figure out how many 3 months increments are in Y years. Well, 1 year is equal to 4 3-month periods. So 3 months like a quarter. So you have 4 quarters in a year. So after Y years, you'll have 4Y quarters. And each quarter is 3 months. All right, so that means that you will need to multiply by 2 4y times. And a shortcut of doing that is an exponent. So it's really 2 raised to the 4y power. So that's how many times you have to multiply by 2. Now, you don't want to start with b. The starting point is actually b over 8. So you multiply the original, which is b over 8, by 2 4y times. So that's 2 raised to the 4y power times b over 8. And this is the start. And this represents how many times you double. All right, now this doesn't look like any of the choices, but that's because you can actually rewrite this. So b over 8 is really b over 2 cubed, because 8 is 2 cubed, and you're multiplying by 2 to the 4y. And you can actually use the law of exponent there, because this is really a fraction. Remember, 2 raised to 4y is a whole number, so there's really 1 in the denominator. So this is b times 2 to the 4y all over 2 cubed. And this is the part that you can use the law of exponent. B to the a divided by b to the c is b to the a minus c. You want to subtract the exponents when you divide. So this would be b times 2 to the 4y minus 3. You want to subtract these two exponents. And that's why the answer is choice B. That's why you have to subtract 3 to the exponent there, because it's really this 8 that you're dividing by. The other way to do this is to just figure out what the cards will be after, let's say, 1 year, and then just go through all the choices and make sure that everything is correct. So you can always plug in as well. All right, and here's a summary for this page. All right, thank you everyone for joining, and I'll talk to you guys in the next one. All right, bye everyone.